Dear students, welcome to this session. In this session, we are going to look into lab program number 7, implement using functions to check whether the given number is prime and display appropriate messages. No built-in math functions. So, what we are going to do in this particular lab program is we have to check whether the given number is a prime number or not. So what is a prime number? Prime number is a number which is divisible by 1 and itself. Example, number 7. Number 7 is only divisible by 1 and 7. Number 7 is not divisible by any other number. So a number which is divisible by itself and 1 is called as a prime number. Example of a number which is not prime, 6. 6 is divisible by 1 and 6, that is itself, and also it is divisible by 2 and 3. Hence we cannot say 6 is a prime number. So our program has to check whether the given number is a prime number. That means it is divisible by itself or 1 only. And another important thing about this lab program is we have to implement functions. So here we have to show the usage of the functions. So we are going to create a function which will we pass a number to that particular function, and in return it will check whether it's a number or whether it's a prime or not. So what is the logic? This is the problem statement. What is the logic we are going to use? Logic is very simple. Let us say we get the number n. N is the number. Then we are going to divide it by 2 first. We are not going to divide it by 1 because every number is divisible by 1 and itself. So first we are going to divide it by 2, and we are going to check whether the remainder is 0. For example, if given number is 4 and 4 modulus 2, if I take how we get the remainder directly, the remainder will be directly got using the modulus sign, okay, or modulus operation. If I say 4 modulus 2, then that is equal to 0 because the remainder becomes 0 because 4 is perfectly divided by number 2. Another example, number 5 modulus 2. So 5 modulus 2, that is 5. When we divide 5 by 2, we get a remainder of 1. So that is not a perfect division. So when that happens, then we move to the next number. First we divide by 2, then we divide by 3, whether we check whether the remainder is 0. Then we divide by 4, we check whether the remainder is 0, and we keep on incrementing the numbers, and we will divide the given number by the incremented number and check whether the remainder is 0 or not. If any time the remainder is 0, then we will say it is not a prime number. Let us say this particular number is not divisible by n minus 1. N is the given number, and we are not going to divide by n because every number is divisible by n. We are going to try until n minus 1. If until n minus 1 that particular number is not divisible, then we will say it is a prime number. And if in between it the n is divisible by certain number, then remainder would be 0, and then we will say it is not a prime number. That is the logic we are going to use. Now first here how to declare a function. So in this case we have 3 important parts whenever we are using a function. First one is the function declaration. What is function declaration? Function declaration, you are telling the compiler explicitly that you have a user defined function, and you will also tell what is the return value of that particular function, what is the name of the function you are going to use, and what are the parameters and data types you are going to send as a argument, and followed by a semicolon. So what is the how we do the function declaration? Function declaration will have the return type, integer, float, etc. Return type will be there. Name of the function, name can be any valid identifier, bracket, list of arguments, okay, list of arguments and their data types. In this particular case, the function name is prime, and it will take one argument of integer type, and this function will return one integer, and it ends with a semicolon. The function declaration has to be done before main and after the hash include stdio.h. So this is the function declaration. Now compiler will know there is a function called is prime, and which takes one argument and it returns one integer value. Main method, main parenthesis, open curly brace and closing curly brace. This is the start of the program and this is the end of the program. In this particular program, we need two variables. One is n, that is the number which user is going to give, and we are going to use a flag. Flag is basically used to check. We will set the flag in such a way that if it is 1, then it is a primary number. If it is 0, it is not a primary number. So just to indicate whether the number is prime or not, we need one flag. After that, we are going to read the number. Before reading the number, first we use the printf statement to inform the user, or to display on the console saying that enter the number. So printf, whatever is inside the double quote, it will be printed onto the console. Enter the number will be printed, and scanf, then the scanf runs. What the scanf will do? Scanf will read the input from the keyboard. So scanf function will keep on waiting until user gives a value, a number, and hits enter key. And when user hits the enter key, that particular number is stored in the variable n. Okay, and we have the format specifier %d because n is a integer data type. So syntax is scanf bracket inside the double quotes %d comma %n, and we know ampersand is a address of this is address operator, address of n, and close the parenthesis and semicolon. Flag is equal to is prime and inside the bracket n and semicolon. What is this? This is called as a function call. This is a function declaration. This is a function call. Function calls are, you are going to just have the name of the function, and inside the bracket you are going to send the actual values. In this case, what is the actual value? Whatever is the user given values. Let us say user has given the number as 10. The function is called as is prime of 10. So that 10 value will go. Once this function is called, we will see the logic. What this function will do, it will check whether n is prime or not. How to do that? We talked about the logic. If we have a number n, we are going to divide it by 2, 3, 4, 5, so on until n minus 1. So we are not going to divide it by 1, and we are not going to divide it by n. We are going to divide it by all other numbers 2, 3, 4 until n minus 1. If any time the division results in a zero remainder means it is perfectly divisible by that particular number, then immediately this function returns a value of 0. The flag will be 0. And if this number is not divisible by any number between 2 and n minus 1, then it returns a value of 1. Okay, that logic we will see soon. So if the value comes as 1, that means what? It was not divisible by any of the numbers between 2 and n minus 1. Then we check the flag. If a flag is equal to 1, that means the given number printf, the given number, that is n %d, is a prime number. If flag is equal to 0, so flag is equal to 1 means it is true, it is a prime number. If flag is equal to 0, else condition is satisfied, the given number is not a prime number. Now we'll see the function is prime function. Okay, now you can see the is prime, int is prime, bracket int of n, then open curly brace, closing curly brace, and we have all the instruction inside. This is called as a function definition. Whenever you are using a functions in C programming, we must have a function declaration, function definition, and the function call. And where the function declaration is done, before the main method, and where the function call is done, inside the main method, normally inside the main method, or function can be called from anywhere. And the third thing is function definition. Function definition will have a return type, function return type, name of the function, and a pair of parentheses. Inside that we have the list of arguments, in this case one argument int n, and we don't put a semicolon. This statement is almost exactly same as the declaration statement, except that we don't have a semicolon. We don't put a semicolon. Instead we have open curly brace and closing curly brace. Inside we will have the statements. For your knowledge, just I will show the declaration, which is exactly like this, just a additional semicolon is there. So you can see int function name and list of arguments, semicolon, and the function definition is also same, no semicolon here. Inside the function we have one variable, local variable, inside the is prime function, and we are going to loop. So what we are going to do, we are going to divide the given number from 2 to n minus 1. So we need not go up to n minus 1. What we can do is, suppose if the given number is 10, so normally our logic is if you try to divide it from 2 to 9, if anywhere it is divisible, then you can say it is not a prime number. If it is not divisible, then it is a prime number. Instead of going until n minus 1, we can go just up to n by 2. That is, n by 2 is, if given number is 11, 11 divided by 5, 11 divided by 5 is 11 divided by 5, that is 2 point something we will get, 11 divided by 2, not 5, 11 divided by 2 we get it as 5.5, so the whole number is taken as 5. So if I divide 11 using 2, 3, 4, 5, I will come to know whether it is a prime number or not. So here you can try either n by 2 or n minus 1, both will work fine. Only thing is, in case of n minus 1, if it is not a prime number, if it is a prime number, there will be more number of loops, but this will work perfectly fine. For loop I is equal to 2, I less than equal to n by 2, and I plus plus. Inside here what I am doing, n modulus I means first value is 2, n modulus 2. If given example, user has given 11, we get 11 here. 11% 2, 11% 2 is what? 1. So 1 equals to 0? No. So this if statement has only a true statement, true block. There is no else. So it will go to the next iteration. I will become 3. Then 11 modulus 3. What is 11 modulus 3? I guess it is 2. 2 equals to 0? No, false. So it will not execute this. So it will keep on doing this. And in our example, then from 3 it will become 4. 11 modulus 4. Okay, maybe 11 modulus 4 is 3. 3 equals 0? No. Then it will go again. Then last number is 5. 5 is the value. 5 less than equal to 5, answer is 2. Then 11 modulus 5, 11 modulus 5 is 1, 1 equal to 0, no. Then I will become 6, 6 less than equal to 5, false. Then it will come out of the loop, then it will return 1. And if it returns 1, to see, this is the function call, so 1 will be stored in the flag. If flag this value is 1, 1 is equal to 1 is true, the given number is a prime number. Let us say if given number is a 10, then what happens? I is equal to 2, I less than equal to 10 by 2, that is 5, and I plus plus. First, if 10 modulus 2, what is 10 modulus 2? 0, because it is perfectly divisible, remainder becomes 0. 0 is equal to 0, then what we will do? We will return a value of 0. So this function, this is the function call, this will get a value, return value as 0, and that 0 is assigned to flag. Now flag is equal to 1. Is it is equal to 1? No, because it is 0. Then else condition, the given number percent d, that is 10, is not a prime number. That is how it is done. So how you will get the, if you run the program, if you compile and run the program, this is how you will get the output. Enter the number 19. The given number 19 is a prime number, because 19 is not divisible by any other number other than 1 and 19. Enter the number, I give it as 25. The given number 25 is not a prime number, because 25 is divisible by 5. So we will see the execution now. Okay, and for the execution part, we are going to use the JDoodle C online compiler. So here I have already entered the program, so same program is there, the same program, everything is the same. Okay, only thing is I have included int in the main, so that will reduce one warning in case of a JDoodle C online compiler. So I have this function is there, and now standard input I will give 19. We will take the same example, 19, and I will say execute. So here you will see the output. 19 is a prime number. Okay, the given number 19 is a prime number. Now we will give a value of 25 and we will execute. You can see the given number 25 is not a prime number. Now we will see the flow chart. Okay, so this is the program, simple, very simple program, and this is the flow chart. Lab program number 7, a prime number, main program. We have a start of the program, read a number n. Okay, I will show you. This is the start of the program. First is read a number n. Read a number n. So it's a parallelogram shape, so that it's a input and output is a parallelogram. And next one is the function call. This is a function call. Flag is equal to is prime of n. So whenever we have a function call, we will have a rectangular box with the additional line on both the ends. So this is a representation of a function call. Once the function call is done, this function will return a value to the flag. Then we are going to check what value it has returned. If flag is equal to 1, if answer is a true, it will display n is a prime number, and if flag is equal to 0, let's say flag is 0, this condition becomes false, display n is not a prime number, and then it will stop. After, if it follows this path, if it is a true, if it is 1, it will display it is a prime number and stop. If it is 0, then it will display it is not a prime number and it will stop. Next is the function. So function flowchart. This is a separate subset of the flowchart. We have function as a rectangular block with additional line on both the ends. Function is prime bracket n, initially I is equal to 2. So this is the for loop. So I will show you the program. What we have inside the function, we have for. First statement that is executed is I is equal to 2, and after that, what is the statement that is executed? Whether I is assigned with the value of 2, then it is checked whether that value is less than or equal to n by 2. First I is equal to 2 initialization. After that, it will check if I is less than or equal to n by 2. If answer is true, then it will go inside. If answer is true, it will come here. There is one more if condition. What we are checking? N modulus I. I is this value, whether it is equal to 0. You can see here, if n modulus I equals to 0. If answer is true, meaning that means that number got divided perfectly, remainder is 0. So we return from here. When we see return 0, the control will go back to this place. Okay, so the control will come, the function will get a value with a 0, then flag is assigned with the 0 value. The main function will have start and stop. Function will have the function block and return. It ends with a return, and when it is returning, either it can return a value or it can just return the control. So some of the programs are like void. In that case, function will not return any value, but it will just return the control back. Now if I is less than equal to n by 2, okay, if this condition is true, it will check n modulus I is 0. This checks if remainder is 0, then it will return 0. Let us say this is not equal to 0, this condition is false, then I value is incremented, I is equal to I plus 1, and again this condition is checked, I is less than equal to n by 2. As long as I reaches n by 2, if 10 value is given, I will loop for 5 times. If n value is given as 11, then it will loop for 5 times, okay, until the value is 5. So 2, 3, 4, 5, that is 4 times it will loop. And if it is a 10, if it is a case of a 10, first instant itself it will become 0. 10 modulus 2 is 0, it will return 0. So if this condition becomes false, if I is less than equal to n by 2, if this condition is false, that means what? None of the numbers could able to divide this value n. So that is false, we return value as 1. So return of value 1 means what? It is a prime number.